Hello everyone, we are at Beyond the Formula. Let's find out where does a capacitor actually stores energy. So when we charge a capacitor, suppose I have a capacitor this of capacitance C. If I charge this capacitor using a battery of voltage V and a key or switch S, if I close the key, current flows. Alright, current flows. What we have previously seen is what? The electrons comes here, right? Electrons comes here. It comes out from the negative terminal and comes in at positive terminal. And at the capacitor side, what happens? One electron is taken from the plate and another electron is injected to the plate, right? So what happens? One plate becomes negatively charged and another plate becomes positively charged, correct? Now when you charge this capacitor, is the energy is the energy is the energy is stored in the metal plates or somewhere else So where is this energy stored? We say, what do we say? Capacitor is the energy storing device, right? Charge storing device. It stores the energy. Now let's find out what happens. What actually happens here is, see, suppose I have this capacitor connected with a battery. When I close the switch, what happens? Initially at t equal to 0, or you say t less than 0, when switch was opened. S open. S was open. This is S, switch S. Now here we have plus charges, we have minus charges, right? All type of charges we have, right? Because it is a conductor. It has free electrons, plus charges, minus charges. Similarly here, plus charges, minus charges everywhere, correct? Now when you at t equal to 0, you closed the switch. S is equal to closed. Now what happens here? Now what happens when you close the switch? An electron is taken here, right? And an electron is injected here. An electron is taken from this side, from left hand side, and an electron is injected to the right hand side plate, correct? So initially it is easy to take few electrons or one or two electrons from left hand side, right? What happens when only positive charges remained here, or majority charges is positive charge and here majority charges is negative charge, right? So let's see here again. After some time, what happens? T greater than 0, what happens? We have majority charge as positive charge and majority charge as negative charge. Few positive charge, few negative charge. Alright. Now what happens? If you try to take an electron from this side and if you try to inject an electron at this side, what happens? This positive charge and this negative charge, this positive charge and this negative charge applies force of attraction and repulsion. Here force of attraction, and here force of repulsion, right? Here force of repulsion. So what happens? This battery has to do work, against what? Against the electric charges, force of attraction and repulsion. Correct? It is not easy to take this electron or inject this electron against these charges. Here what? Force of attraction, as positive attracts negative, and here force of repulsion, as negative repels negative. Correct? Now you see this work done by the battery, against electric charges, repulsion and attraction, is stored. This energy, this work done is stored in form of energy, Now you see, after this capacitor is fully charged, after this capacitor gets fully charged, suppose say plus q and minus q, the total charge, the charge is plus q and minus q. So what we see here is the charges are on the plates. These charges are on the plates, lying on the plates. So why not say that energy is stored on plates? Why not say energy is stored on the plates? So what happens is the plates only creates what? The plates only creates electric field. The plates only create electric field in the space between them. The plates only create electric field in the space between them, and it is this electric field that has ability to do work. It is this electric field. This electric field has ability to do work, or we can say to apply electric force if some charges appears or emerges. So what happens? Therefore, what we can conclude is, therefore the energy is stored in the electric field between plates of capacitor, right? You might have seen the equation of energy as half CV square or Q square over 2C, right? We can derive the equation. We will derive in the future videos. We will derive the same equation in the future videos, right? So what we can conclude here is a capacitor stores energy because battery does work to separate charges. Battery does work to separate charges. This separation creates an electric field, and the energy is stored in that electric field, not inside the plates. Correct? Thanks.